Hey everyone, welcome to your PlayPosit for the day. We are going to be going over properties of exponents. So we're going to reduce some exponential expressions. We're calling all of those powers and properties. We're going to look at different multiplication rules and division rules. And we're just going to keep working and practicing towards progress, right? Not perfection. Let me grab a pen tool. All right, first we're going to recall, what does it mean? And we've been doing this a little bit this past few weeks. When you have a number to a power, if you have a 2 here, it means we're going to write it twice. So squared means it's 7 times 7, which we know is 49. Same thing with a 3. With a cubed, we would write it 3 times. Well, how about these, right? 2 to the 7, we would write it 7 times. So we're going to see these numbers, the powers get much larger. 3, we would write it 5 times. So this number here is called the base, and the small number is called the exponent. So you write the base however many times the exponent exists. Well, what about this? When we have the numbers where the bases match, we can perform some operations. So we would have 2 to the 7th, that's going to be 7 of them, and 2 cubed, that's going to be 3 of them. So we went ahead and expanded this out, right? Well, what if you wanted to condense it again? How many 2's are there? There are 10, right? So this is just another way to write 2 to the 10. How about down here? We would write 3 squared, so that's twice, and then to the 4th. 1, 2, 3, 4. How many are there? 1, 2, 3, 4, 5, 6. There are 6. Are you seeing the pattern? Are you seeing the rule? The multiplication rule for exponents are if the bases match, guess what? You add the exponents. So you don't have to expand it all out and count it. You can just add them. All right, our next rule, distribution with exponents. So we're used to, when we see a parentheses, we know that means to distribute and multiply. So this exponent here on the outside is going to go to everything on the inside. So that means x to the m times n. We're going to see some examples. So this 4 is on the outside. We're going to distribute it to the exponent. So that'll be 3 to the 2 times 4, which is 3 to the 8. Over here, the 4 is going to go to everything. It's going to go to this exponent. Well, there's no exponent there, but there's always a 1. And to this exponent. So we're going to have -2, the whole thing, to the 4 times x to the 4. And that's it. So when you see exponents, we are going to distribute. When you see parentheses. Division rule. What happens when we divide? So we're going to kind of do the same thing. We're going to expand the top. There's 5 5s. 1, 2, 3, 4, 5. And there's 3 5s on the bottom. If you look, your gut might be telling you, hey, I can reduce this, right? 5 over 5, that's 1. 5 over 5, that's 1. Here's 1. So what do we have left? We have 2 5s on top. You can write it like this. So what is happening? We had 5 on the top, 3 on the bottom, and we actually ended up with 2. We're actually subtracting. So when the bases match for division, we subtract the exponents. So for multiplication, we add, and for division, we subtract. Let's look at this one. The bases match, right? X and X. 5 over 4, You can expand it all out if you want to and divide, or 5 minus 4 is 1. So you would have 1 left on top. And of course, we could reduce 2 over 4, right, to 1/2. And that's it. Okay, something that's kind of elusive, kind of cool, is that anything to the 0 power equals 1, always. And I'll show you why if you think about it. Like, let's say we had 2 to the 1 over 2 to the 1. And using our division rules now, what would we do with the exponents? Because the bases match, we can subtract them. So this would be 1 minus 1. Look, 1 minus 1 is 0. But hey, look, what is 2 over 2? It's just 1. So anything to the 0 power is always 1. We could do anything. 7 to the 0 power. It's the same as writing 7 to the 1 over 7 to the 1 because of our division rule. 1 minus 1 is 0. But also 7 over 7 is 1. So it's kind of like a synonym. It's just another way to write 1. Anything to the 0 power is 1. Okay, our last sort of topic we're going to review are negative exponents. Remember when we were rationalizing the denominator, right? It's not technically like wrong, but it's also not really right, right? So it's just much more simplified when we don't have the radical in the denominator. So we would multiply by whatever it was. Remember doing this? And we'd have root 5 over 5. Well, it's kind of similar with negative exponents. We just don't like negative exponents, and we can make them positive. And the way we do that is we move them, move it. So we can always make this a fraction by putting it over 1. And if it's on the top, all you do is move it to the bottom. So this will be 1 over x to the 1. How about this one? The negative exponent is on the bottom, so we're just going to move it to the top. This one, we have a parentheses, so we're going to distribute the 2 to all of the exponents. So we would have 2 to the negative 2 times 2 to the 6. Now let's put this over 1, and we will move the negative part. And move it to the bottom, it becomes positive. And look, we can keep going and subtract. 6 minus 2 is 4. We're done. So the rule for negative exponents is you move it. And we can talk about why in person because it's a lot more fun to explain that in person. So let's try some. Which of the following is equivalent to this? So we're just going to take it a step at a time, making sure we handle those where the bases match. So looking at the A's first, we're dividing. So we would subtract the exponents. 12 minus 3 is 9. We have 12 is bigger, so the 9 will stay on top. Then we have 2 minus 6. 6 is bigger, so the B will stay on the bottom. That's it. 9 over 4, it's A. If you forgot the rules, you could always expand this out. You could write 12 A's, and 3 A's, and you could cross them out and see how many are left. You can always do that. Here's another one. I love these. They're fun, like little puzzles. We're going to line up our bases. 18 over 9, that's 2 on top, right? 8 minus 3, that's 5 on top. And 9 minus 6, that's 3 left on top because 9 minus 6 is 3. So this matches A. A again. All right, our last one. We have some parentheses. So we're going to distribute the exponents to everything on the inside. The 2 goes to the negative 4, and the 2 goes to the 1 here. So we'll have 3 squared times x to the negative 8, right? Negative 4 times 2 is negative 8. And then there we go. So we're multiplying. This is really 9, right? We can make this a 9. So 9 times 5 is 45. And remember, when we multiply, we add the exponents. These are the same bases, so we can do that. -8 plus -2 is -10. But we want to make it positive, right? So we're going to move the negative part. So we'll have 45 on top and x to the 10 on bottom. Let's find our answer. Here it is. All right, everyone. This is a super quick PlayPosit this week. If you have any questions at all, please always reach out. We have some extra resources on the website for you to practice these, and I will see you in class.